Here we have a SAT math problem. Okay, let's go to the question. Your function f is defined as f of x equals to ax cube positive bx square negative 81 ax negative 81 b, and the factor form of f is f of x equals to 2x positive 3 times x positive d times x negative d. If c square equals to d and c is less than 0, then what is the value of a positive b positive c? Okay, here we have the function f of x, and also we have the factor form of the function f of x over here. Okay, now what I'm going to do is I'm going to factor the expression we have over here. When I factor this expression, then I will have the factor form of the function f of x. It can be compared with the factor form which is already given in the question. In that case, I'll have a chance to get the values for the constants, the a, b, and also the c. Okay, now let me factor the expression we have over here. Okay, let me take the given function as it is. That is f of x equals to ax cube positive bx square negative 81 ax negative 81 b. Okay, then we get f of x equals to, so what do we find in common in the first two terms? I mean, what is the greatest common divisor of ax cube and bx square? That is clearly x square. So we can factor x square out from the first two terms. When x square is factored out, to get the stuff inside the parenthesis, we have to divide both the terms by the one I factor, that is x square. When I divide the first term ax cube by x square, I'm just getting ax. When I divide this one by x square, I'm getting positive b. Okay, here I find negative 81 as the greatest common divisor for these two terms. So I can factor negative 81 out. Now to get the stuff inside the parenthesis, we have to divide both the terms by negative 81. When I divide this one by negative 81, I am getting ax. When I divide this negative 81b by negative 81, I am getting positive b. Okay, then f of x equals to, here the greatest common divisor for these two terms is ax positive b. So we can factor ax positive b out. Okay, then we have x square left in the first term and negative 81 left in the second term. Okay, then we get f of x equals to ax positive b times x square negative. This 81 can be written as 9 square because the value of 9 square is equal to 81. Okay, now let me consider an identity in algebra, that is the difference of two squares, a square negative b square. So whenever we have difference of two squares in this form, a square negative b square, it can be written in the factor form, that is a positive b times a negative b. Usually we remember this one because it's an identity in algebra. Now let's consider this particular stuff we have over here. It's exactly in the form of a square negative b square. At the place of a we have x, at the place of b we have 9. So now actually it's a difference of two squares. So we can write this one in the factor form like this one. For that, we have to write x at the place of a and 9 at the place of b. The same thing we have to do over here. Okay, let me do it. That is f of x equals to ax positive b times x positive 9 times x negative 9. I just write this one in factored form using the identity we have over here. Okay, now let me take the factored form of the given function. It's over here. Let me write it. That is f of x equals to 2x positive 3 times x positive d times x negative d. Okay, when I consider the first factor over here, ax positive b, it's exactly in this form, and when I consider these two factors, they are in this form, x positive d and x negative d. So comparing this one and this one, we get a equals to 2 because at the place of a we have 2, at the place of b we have 3. So we get a equals to 2 and b equals to 3. Okay, comparing these two factors and the two factors x positive d and x negative d, clearly we get d equals to 9. Let me write the value of d equals to 9. But if I want to get the value of the expression a positive b positive c, I need the value of c. I got the value of a, I got the value of b, but still I have to get the value of c. For that, we have to use the information we have over here, that is c square equals to d and c is less than 0. Okay, now let me take this particular piece of information. Let me take that c square equals to d. Okay, c square equals to, we got the value of d is 9. Let me write it over here. Okay, now to get the value of c, we have to get rid of the square we have over here. For that, we have to take square root on both sides. Okay, whenever I take square root on both sides of an equation, for one of the square roots, I have to consider positive or negative sign. Usually, we consider positive or negative sign for the square root which contains number inside. So this square root contains number inside, that is 9. We can consider positive or negative sign for this square root. On the left side, the square root and square will cancel out. C equals to positive or negative. We know that the value of square root of 9 is 3. Okay, we got two values for C. One is C equals to positive 3 and other one is C equals to negative 3. But the question says C is less than 0. C is less than 0 means C is negative. So negative means we have to consider this particular value of C. We can reject this one. Okay, now I got the value of C as well. That is C is equal to negative 3. Okay, now let's evaluate the value of the expression A positive, B positive, C. So the value of A is 2. The value of B is 3. Positive, the value of C is negative 3. Then we get 2 positive 3 is 5. Positive times negative is negative 3. Okay, 5 negative 3 is 2. Okay, now I got the value of the expression A positive, B positive, C. Its value is 2.